Today we will be discussing about the assignment in which we are taking cutoffs for 6 to 7 past years of KCET, and we'll be extracting a particular college with three of its branches and plotting the regression models of it. All right. So starting with, here is the question that we'll be discussing: identify a college and three branches. Extract cutoff ranks for general category for all the years. Write the Python code to visualize the distribution of cutoff marks and all these things. You can pause the video and read it. Let me just quickly show you the data format that we'll be using. So these are the Excel sheets that we'll be using. You can use any other data format if you want. Make the adjustment as per your convenience. All right. Starting here, we have defined the initial function, that is get cutoff, and the inputs will be file path and sheet name. Sheet name will be because I have multiple sheets in my Excel. That is why I have given sheet as an input. If you don't have, you can just skip this argument over here. The libraries that we are using are pandas. All right. So you can will here we are using uh, pandas.read excel, file path and sheet name. Then this is the college name that you will be, you know, that we'll be looking for, as I have chosen this college. If you have any other college, you can just remove this and put the college name as well. It will work for it. All right, this line of code over here will search for this college name in our table, in our sheet, and at whichever index it find, it will assign that index to matching rows. We'll check if matching rows is empty or not. If it is not empty, then we'll assign the row index. Okay. Generally, all the cutoffs are within 10 rows of the 10 rows below the college name that we have found. So this line of code executes that part where we're using just 10 rows below the college name that we have found. Otherwise, it will be too big of code. I have chosen these branches: CS Computers, EC Electronics, and E Electrical. You can choose whichever branch you want and just add any other branch over here. All right. Now, here we are iterating through the specified range of rows. This is just simple code for row in range. ilock, is we all know, is used to iterate through rows. Now, what we will do is we'll check if our row is equal to our list element or not. If it is equal, then we'll take our column name GM and we'll assign the subsequent value of column GM to the list that we will creating that we'll be creating further on. Moving ahead, these are the empty lists that I have created: CS cutoffs, AC cutoffs, EE cutoffs. You can use any other data format as per your choice. Right. These are the function calls that I've given for 2016, 2017, 2018, 2019, 2020, 21, 22, and 2023. And as I told you, I have multiple tables. So I've given the table input as well. These are my uh, lists after assigning the values. So here you can see I have multiple elements in each of the list containing the. After that, we'll be working on the regression model. Here you can see we have used years 2016, 17, 18, 20, 21, 22, and 23. Now for regression model, we have inbuilt libraries, sklearn, and inbuilt function linear regression. So we'll be using that over here. Just import these libraries. And first we'll be creating a linear regression model for each set of cutoff. Then we'll be reshaping our 2D array to fit the data, and then we will use the inbuilt models to fit the data. That is to generate the regression models. Using this cs model.fit, ec model.fit, and double e model.fit. And then we will use this command for predicting our regression model. Once it is done, we'll be doing the plotting. Firstly, we'll plot the original cutoffs, then we'll plot the regression line, and then we'll put both of them together. As we can see, these are the cutoffs. This is the regression model, and this is the regression model for both of them combined. We can see that, and what we can observe this and make conclusions and inferences as well. As we see, this red line over here is CS cutoff, this green line is EC cutoff, and this blue line is triple E cutoff. As we can see, the electronics and computer science have faced very slight increase in cutoff over the years, so nothing much has changed. But if we see electrically, it has increased a lot, which means that the demand of core branches is decreasing very significantly. Now, there can be multiple reasons for that. That